Today we're going to talk about data analysis. When you're talking about data analysis, before we can talk about analyzing data, you first have to take sample types. You have to collect the data. In order to collect the data, we want to talk about the different types of ways that we can collect data. So first, we're going to talk about sample types. What is a sample? A sample is a selection taken from a larger population. Population being what you're sampling. It could be people, it could be animals, whatever you're sampling, it's called the population. You're sampling sandwiches, that's the population. So let's look at the example. At a football stadium with 40,000 people, you ask 100 people what they do for a living. The sample size are the people you asked. How many people did you ask? 100. The population is the total group that's there. So I asked 100 out of 40,000 people. So let's look at the different types of samples. First, you have the random sample. The random sample is a selection that is purely made by chance with no predictability. That means you didn't do anything to sway how you chose the people that you asked or how you collected your samples. There was no way that you could predict who you were going to ask. So here's our example. At a football stadium with 40,000 people, you randomly pull 100 tickets out of a hat and ask the people seated there what they do for a living. It's this word right here. Randomly. You randomly pulled 100 tickets. So I'm still only asking 100 people out of the 40,000 people in the stadium. However, the big question here is, did everybody in the stadium have a chance of being surveyed? And the answer there is yes. That's what makes it random. Everybody had an equal opportunity to be a part of the survey. There was nothing that was like, well, you can't do it or you can't do it. Anybody that was in that stadium got a chance to be surveyed. So let's talk about the next type of sample, which is a biased sample. A biased sample is a selection that is made where one or more groups is more likely to be selected than another. More than one, they're more likely to be selected than another group. So we are still in the same football stadium with the same 40,000 people. I'm still only asking 100 people, but this time I'm specifically only asking the people in section 34, what they do for a living. So my sample size is still 100 and my population is still 40,000. However, everybody does not have a chance to be surveyed. Anybody who is not sitting in section 34 does not get a chance, which is what makes this a biased sample. Another example is when we did our 8th grade superlatives. The only people that had a chance was the 8th graders. That was a biased survey. The only people who got asked and the only people who could win were 8th graders. It's biased because we only chose 8th graders. The 6th graders and the 7th graders did not have a chance to be a part of that survey. The very last type of sample that we're going to talk about here is the representative sample. The representative sample is one that is proportional to the population. So that basically a representative sample is when you're using a smaller sample to describe what a larger amount would be. So let's look at the example. I want you guys to see what I'm saying. So I'm still in the same football stadium. I asked 100 people what they did for a living. Finally, I find out that of those 100 people, 15 of them are lawyers. That is a smaller sample of the 40,000. So we can use a proportion to guesstimate or guess if 15 out of 100 people are lawyers, then we can technically say, using that information, we can try to find out how many out of the 40,000 people in the stadium. We can use that information to try to estimate how many out of 40,000 would be lawyers. What you're going to do is you're going to set up a proportion. 15 over 100 equals X over 40,000. If you guys have forgotten, remember, cross, multiply, then divide. If you forgot the steps. So I'm going to multiply 100 times X, which is going to give me 100X. And then I'm going to multiply 15 times 40,000, which is going to give me 600,000. That's cross multiply. Now I'm going to divide. Divide by the number that is with the variable. This is a one-step equation. So when I divide, that cancels out and I'm left with X equals 6,000. So I can estimate that if 15 lawyers out of 100 people sampled, 15 of them are lawyers, then I could just say there are possibly 6,000 lawyers in the stadium. Possibly. Not exact, it's just an estimate. Okay, so now we know how to collect our samples. Now let's look at how do we analyze the data that we've collected. So next, let's talk about data analysis. How are we going to analyze this data? Well, in order to analyze data, you use the measures of central tendency. You can use mean, median, mode, and range, and outliers. Outliers is what we're probably going to be focusing most on today. When we analyze our data, we want to look at, first, let's review the mean. What is the mean? Mean is the average of the numbers. You add up all the numbers and divide how many numbers there are. Divide by how many numbers there are. Median. Median is the middle number. You must order the numbers from least to greatest. If you don't put them in order, you will choose the wrong median. If there is no middle number, you have to find the average of the two numbers in the middle. Add them and divide by 2. Next, you have the mode. Mode is simply the number that appears most. If a number appears the same amount of time, it is possible to have no mode. And it is also possible to have more than one mode. So if two numbers appear multiple times, but it's the same amount of times, then it is no mode. Let's look at range. Range is the difference between the lowest and highest value. So you're going to take the larger number minus the smaller number. It will give you the range. Last but not least, we have the outlier. Now, the outlier is what we're really going to be focusing on here today, because the outlier, it is a value that lies outside of the data, which means it is either smaller or larger than most of the other values. It's an outlier because it's bigger than all the other numbers, or it's really, really small compared to the other numbers. First, let's look at how do you choose which circumstance would be the most appropriate one? Well, look at this little chart I have for you. Finding the average is most useful when there are no extreme values. So if there are no outliers, no super large numbers or super small numbers, the best method to use is finding the average. The median is the data has extreme values, but there are no big gaps in the middle. So the outlier does affect the median, but not much at all. So the median is all about what's in the middle. The mode is, when is the best time to use the mode is when you have a lot of repeated numbers. So now we are going to practice finding the mean, median, mode, and range of this data. Assuming we went out and we collected some data from from 6 people, and we asked them their shoe sizes. Of these shoe sizes, do we see an outlier? The answer here would be yes. 12 is the outlier. 12 is much larger than the other values from my data. Now we are going to talk about how does the outlier affect the mean, median, mode, and range. So we're going to go through and we are going to calculate each one of these with the outlier and without the outlier. So first, we're going to talk about the mean. Now, I gave you the steps right here so that you didn't have to keep scrolling up to the top of the page or looking up at the top. Add all the numbers and divide by the sum. Divide the sum by the numbers of numbers, by the amount of numbers. Number of numbers. All right, so first we're going to do with the outlier. So with the outlier, I'm going to add 8 plus 6 plus 7 plus 5 plus 6 and plus 12, and that gives me 44. I'm going to take that 44 and divide it by 6. Because there are 6 numbers, including the outlier. 7.3. So that means my average with the outlier is 7.3. Now we are going to calculate my average without the outlier. So I'm going to take these same numbers, add them together, 8 plus 6 plus 7 plus 5 plus 6. But I am not going to include 12 because 12 is my outlier. So this gives me 32. I'm already noticing that without the 12, my sum went down. My sum decreased. So then when I take 32 and divide it by 5 numbers, why am I dividing by 5? I'm dividing by 5 numbers because when I took the outlier out, there was no longer 6 numbers there. There are 5, which gives me 6.4. So my average amount, my average shoe size is, let's just round these shoe sizes because we are talking about people's feet. So over here, we're going to say its average is 7. And then I'm going to say my average shoe size over here rounds to 6. What do you notice about when the outlier was included compared to when the outlier was not included? I noticed that without the outlier, the average shoe size went down. It decreased. Let's see if that same concept continues throughout our paper here. So we are back. We are now here at the median, the number in the middle. Again, you want to list the numbers in order from least to greatest. Cross off one number from each side until there are 1 or 2 numbers left in the middle. And remember, if there are 2 numbers in the middle, find the average of those 2 numbers, which means add them together and divide by 2. First, let's put our values in order from least to greatest because that's the most important. That's one of the most important parts of median. They must be in order. I'm going to start with the outlier. 5, then 6, then 6 again, then 7, 8, and 12. It says cross off the numbers from each side. So I'm going to cross off 5, then 12, 6, then 8, and then I have 6 and 7 in the middle here. Once I add these together and divide by 2, I get 6.5. Now we are going to do this again without the outlier. I'm going to put them in order again. 5, 6, 6 again, 7, and 8. I'm not going to use 12 because I'm doing this without the outlier. So my outlier is, my median is 6. There is a change, but it's what's considered a slight change. It's not a super big change, so the outlier has a small effect, but it's not a very big effect on the median because the median is all about the numbers in the middle. So as long as there's no gaps in the middle, your median is going to be pretty close together with and without the outlier. So let's look at the mode. Let's see how the mode is affected by the outlier. If all the numbers appear the same number of time, there is no mode. If more than one number appears the most, that is the mode. There can be more than one mode. Or, so there's no mode, there's one mode, and then there's more than one mode. It can go as many as you need. So let's look at our values. Our values are 8, 6, 7, 5, 6, and 12. And mode is the easiest one because all you have to do is look at it. Which number shows up the most? 6. So with an outlier, we included 12 when we were looking at our data. Our mode was 6. Without the outlier, so let's go back and look at our data. And this time I'm not including 12. Which number shows up the most? Still 6. Still 6. Let's make sure that, okay. So there's no change at all. The outlier does not affect the mode at all. Let's look at range. So on range, the steps are, first, put them in order from least to greatest. Subtract the largest number from the smallest, largest number minus the smallest number. Now, with the outlier, the largest number we know is 12 because the outlier is 12 and it's larger than all the other data. So now I'm going to look at my sizes here because the median, we already put them in order, which means the 5 is the smallest and 12 is the largest. So I have to do 12 minus 5. So with the outlier, my range is 7. Now let's do it without. Without the outlier, my largest number is no longer 12. Right here, I'm looking at these because they were in order. My largest number is now 8. 8 minus my smallest number is still 5, which makes my outlier 3. So the range is it's greatly affected by the outlier. Because the outlier is so much larger, with the outlier, it increases the outcome here. So with all that being said, are there any outliers? And how does the outlier affect the mean, median, mode, and range? So first, let's answer this very first question. Are there any outliers? Yes, the outlier was 12. 12 was our outlier. "12 is much larger than the other data. What did we notice about the effects on the mean, median, and mode and range?" So we noticed that there was a pretty big effect on the mean, the mean, and the range. There is a really large effect on mean and range. What did we notice about the effect on the mean and range? We noticed that a larger outlier increased the outcome. So with the shoe sizes, when I included the larger shoe size, it made my average shoe size go up. When I took it out, it made it drop back down. Kind of like your grades. If you have all A's and then you make an F, is your grade going to go up or is it going to go down? It's going to go down because it's a smaller outlier. But if you have all B's and you make a really high A, your grade is going to go up because it is a larger outcome. So with that being said, if a larger outlier increased the outcome, then we know a smaller outlier will decrease the outcome. Now, last but not least, it did ask about the median and the mode as well. And we want to point out here that the outlier had little to no effect on the median and the mode. And that's what we're going to write. The outlier had little to no effect on the median and mode.